So in this particular problem set, we are going to discuss few problems on geometric progression based on its definition as well as the nth term. Now here we have the first problem. So in problem number 1, we need to determine the common ratio of a geometric progression whenever the first term is 1 and the sum of the third and the fifth term is 90. So let's begin. So here it's given here that the first term, which is represented by the letter A in lowercase, has a value equals to 1. Well, and the common ratio, since it's a geometric progression, we need to specify its common ratio as well, and the common ratio be represented by the letter R in lowercase. Now it's also given that the sum of the third and the fifth term is 90. That means we have A3 added to A5, this is equals to 90. Now we know that the nth term of a geometric progression is given by the form a times, where is the first term, multiplied to the common ratio raised to the power of n minus 1. So using this particular formula, then a3 will become a times r raised to the power of 3 minus 1, plus the fifth term will become a times r raised to the power of 5 minus 1 equals to 90. Then our a value, it's given there that the first term is 1, so we have r squared plus r raised to the power of 4 equals to 90. Rewriting this, we'll get r raised to the power of 4 plus r squared minus 90 equals to 0. Now this is a biquadratic equation, so we can find out the value of r by factorizing it to get r raised to the power of 4 plus 10r squared minus 9r squared. So that means we will now have r squared. If we take it as the common factor, we can combine the first term and the second term. Then within the parentheses, we're going to get r squared plus 10 minus, so we're going to take negative 9 as the common factor and combining the third and the fourth term. So this is going to give us negative 9 multiplied to r squared plus 10 equals to 0. So this is finally going to give us r squared plus 10 multiplied to r squared minus 9 equals to 0. So r squared plus 10, so this cannot be equals to 0. That's because this is always a positive value, and this would mean that only r squared minus 9 can be equals to 0. So r squared will be equals to positive 9, taking the square root on both sides. So we're going to get two values for r, positive 3 or negative 3. So this was the idea. So we needed to obtain the common ratio of the given geometric progression, which has a value. It could be either positive 3 or it could be negative 3. Let's go to the second problem. Problem number 2. So here it's given that the fourth term, the seventh term and the nth term of a geometric progression are 10, 80 and 2560 respectively. Then we need to find out the value of the first term as well as the total number of terms present in the geometric progression. So let's begin. We will first suppose that the first term be represented by the letter a in lowercase. So we have our first term as a, and since it's a geometric progression, we'll need to specify the common ratio. So let the common ratio be represented by the letter r in lowercase. Now it's given here that the fourth term a4, this has a value of 10. Seventh term a7, that has a value of 80. We have our nth term, which has a value of 2560. So we need to obtain the value of the first term and the total number of terms. So let's write it down. So we have to find out a as well as n value. Now we can use the nth term for the geometric progression to rewrite a4. So this will become the first term multiplied to the common ratio raised to the power of 4 minus 1. So this will be r cube. So ar cube is equals to 10. Let's label this as number 1. Then a7, the seventh term will become ar raised to the power of 6 equals to 80. This is number 2. And the nth term an, and that's simply a times r raised to the power of n minus 1 equals to 2560. So let's label this as number 3. First, what we'll do, let's take equation number 2 and divide it by equation number 1. That means we have a r raised to the power of 6 divided by a r cubed. This will be equals to 80 divided by 10. So a and a gets factored out. R raised to the power of 6 divided by r cube will be simply r cube. So r cube is equals to 8. So that means if we take the cube root, if we take the positive cube root, we are going to get the common ratio equals to 2. Now that we have 2, we can use either equation 1 or 2 to obtain the value of the first term. So let's use equation number 1. Now from equation number 1, so we have a times r cubed, so that will be 2 cubed equals to 10. So a will be equals to 8 equals to 10, or a value is 10 over 8, or simply 5 over 4. So this is the value of our first term. Now that we have our first term as well as the common ratio, we can easily obtain the value of n, that is the number of terms, using equation number 3. So let's do that. Now from equation number 3, so let's put in the value. So we have a, which is 5 over 4, multiplied to the common ratio, which is 2 raised to the power of n minus 1, equals to 2560. So with 2 raised to the power of n minus 1, this will be equals to 2560 times 4 divided by 5. The 2 raised to the power of n minus 1, this is going to be equals to, so 5 times 5 is 25, so this is 60, so we'll have 5 times 1, 5, so 512 times 4, so 512, that's 2 raised to the power of 9. Let me write it down here. 512 is 2 raised to the power of 9, and 4 is 2 squared. So when we multiply them, this is simply 2 raised to the power of 9 times 2 squared is 2 raised to the power of 11. So we have 2 raised to the power of 11. Now in this particular equation, we see that the base are exactly the same, so that we can equate the power. So get n minus 1 equals to 11. Solving for n, we have n equals to 12. So that means there are 12 terms in the given geometric progression, and the first term has a value 5 over 4. Let's move on to the third problem. So we need to obtain the geometric progression whose fourth and the ninth term are given. It has a value of 54 and 13,122 respectively. So let's begin. First, we'll need to specify the first term as well as the common ratio. So let the first term be, we're going to represent it by the letter a in lowercase, and the common ratio will be represented by the letter r in lowercase as well. Now it's given here that the fourth term a4, that's 54, and the ninth term a9, so that's 13,122. So we can expand a4, so this is going to be ar cube equals 54, and ar raised to the power of 8 will be 13,122. Labeling this as equation 1 and the other one is equation number 2. So we're going to divide 2 with equation number 1. So we're going to get ar raised to the power of 8 divided by ar cubed, which is equals to 13,122 divided by 54. So r raised to the power of, so a and a gets cancelled, 8 minus 3, that will be 5. So this will be equals to 243. Now we know that r raised to the power of 5, so 243, that's simply 3 raised to the power of 5. So if we take the fifth root, the positive fifth root, then the common ratio is going to be equals to 3. So we have obtained the common ratio. Now we can use the common ratio to obtain the first term. We can use either 1 or 2. Let's use a simple equation. So from equation number 1, we have a times r, which is 3 cubed, equals to 54. So a will be equals to 54 divided by, so 3 cubed is 27. Or if we simplify it, then this is going to be 6 over 3. 9 times 6 is 54, 9 times 3 is 27, or simply 2. So that means our first term is 2. Now that we obtained the first term as well as the common ratio, we can now find out the GP. So our GP will be, it's defined as the first term. The second term will be simply take the common ratio and multiply the first term. So it will be AR. Then we have AR squared followed by AR cube and so on. So we'll substitute the value of A and R here. So the first term will be 2. The second term will be 2 times 3, which is 6. 6 times, all you have to do is, we can consider any term, and to it we're going to multiply the common ratio to get the next term. So 6 times 3 is 18, 18 times 3 is 54, and so on. So this is going to be our required geometric progression. Let's move on to the next problem. Problem number 4. Here we need to obtain the geometric progression when the sum of the first 2 terms is -4 and the third term is a quarter of the fifth term. So let's begin. We'll specify the first term. So let the first term be A and the common ratio be R. It's given here that the first term, which is A, and the sum of the first term and the second term. So the second term is going to be a times r. So this is equals to -4. So this is equation number 1. And then we have the third term, a3. This is a quarter. That means 1/4 times the fifth term. Now we have a5 equals to 4 times a3. So a5 will be ar raised to the power of 4 equals to 4 times ar squared. So here we can simplify this equation. So we have, if we divide both sides by ar squared, we have r squared equals to 4. So taking the square root, our value is going to be +2 or -2. Now that we have the r value, we can use this and substitute into equation number 1 to obtain the first term. So a value, so let's say when our r value is +2, this implies a 1 plus r. So r value is, let's first write it down, a times 1 plus r is -4. So a multiplied to 1 plus 2 equals to -4. So our first term is going to be -4 third. And when r value is -2, that implies a times 1 minus 2 equals to -4. So our a value is going to be +4. So these are the first terms. Well, what we have to do, we have to find out the GP. So let's define the GP now. So we have first case when our a value is +4 and our r value is -2. Then our GP, this is going to be equals to, so the first term will be 4, the next term will be 4 times -2, that's 8. -8 times -2 is +16. 16 times -2 is -32. So this is going to be the geometric progression. And for number 2, when our a value is -4 thirds and our common ratio r is +2, then in that case the geometric progression is going to be, so the first term is -4 third, the next third will be will multiply -4 thirds to 2, so this will be -8/3. Next will be -16/3, and so on. This is going to be the 2 geometric progressions for the given problem. Let's move on to the fifth problem. Problem number 5, we need to show that p squared equals to ab raised to the power of n. So here the first term and the nth terms are a and b, and p here represents the product of the first n terms. So let's begin. So our first term is already given, so we'll only specify the common ratio. So let the common ratio of the geometric progression be represented by the letter r and lower case. Now it's given here that the first term is a and the nth term, which has the formula a times r raised to the power of n minus 1. So here it's given that the nth term is b. So that means we have b equals to a times r raised to the power of n minus 1. So we can divide both sides with a. So instead we have r raised to the power of n minus 1 equals to b over a. Now if we take the n minus 1th root, so that means all we have to do is raise it to the power of 1 over n minus 1 on both sides. Then we get the value of our common ratio. Therefore, we get the r value equals to b over a whole raised to the power of 1 over n minus 1. We will set it aside and label as equation number 1. Coming to the next part of the question, here it's given that the p represents the product of the first n terms, meaning p is simply, we'll take the first term, multiply it to the second term, to the third term, ar squared, and then to the fourth term, which will be ar cubed, and this goes on to the nth term, which is ar raised to the power of n minus 1. Now, we can combine all the a terms together. That means we'll multiply all the first terms together. This happens up to n times, n number of times. And similarly, we have our first term is 1 multiplied to r times r squared. This goes all the way up to n minus 1. So a multiplied to itself n number of times. So this is going to be a raised to the power of n. And we have r times r squared. So this is actually r raised to the power of 1 plus 2 plus 3 all the way up to n minus 1. Now we know that the power of r, so this is a arithmetic progression, arithmetic series whose sum, so let me specify the sum to the nth term of an arithmetic progression that's given by n over 2 multiplied to the first term, which is a, plus the last term. So that means in our case we have 1 plus 2 plus 3 all the way up to n minus 1. So this is going to be equals to, so how many terms are there? So there are n minus 1 terms. So we have n minus 1 divided by 2, and this will be multiplied to the first term plus the last term, which is n minus 1. This is simply going to give us n times n minus 1 divided by 2. So that means our product is a raised to the power of n multiplied to the common ratio r raised to the power of n times n minus 1 divided by 2. Now we can use equation number 1 and replace the value of r with b over a raised to the power of 1 over n minus 1. So let's do that. You have p equals to a raised to the power of n. So we have b over a whole raised to the power of 1 over n minus 1. Then this entire expression is raised to the power of n times n minus 1 divided by 2. So p will be equal to a raised to the power of n multiplied to b over a whole raised to the power of 1 over. So the powers will get multiplied. 1 over n minus 1 times n multiplied to n minus 1 divided by 2. So here n minus 1 and n minus 1 gets cancelled out. So p will be equals to a raised to the power of n times b over a whole raised to the power of n over 2. So we can further simplify. So p will be equals to a raised to the power of n times b raised to the power of n over 2 divided by a raised to the power of n over 2. So we can take this a and combine it with the a in the numerator. So instead we get p equals to a raised to the power of n over 2 times b raised to the power of n over 2. Now when we square both sides, will p squared equals to a raised to the power of n over 2 times b raised to the power of n over 2 whole squared, which is simply going to be equals to a times b raised to the power of n over 2 multiplied to 2. What that means? Simply ab raised to the power of n. So this is p squared equals to a b raised to the power of n, and this is what we needed to show, hence proved. Let's move on to the next problem. So problem number 6, it's given here that the third term of a geometric progression is 4. Then what will be the product of the first 5 terms? That means, let's say the first term, as usual, we're going to define the first term and the common ratio. So let the first term be represented by the letter a, and the common ratio will be represented by the letter r. Here it's given that the third term a3, that's equals to 4. So that means ar squared equals to 4. This is 1. We need to find out the product of the first 5 terms. So the product of the first 5 terms will be, so we have a1 multiplied to a2 times a3 times a4 times a5. First 5 terms. So here a1 will be a, then a2 will be ar, a3 will be ar squared, a4 will be ar cubed. The fifth term a5 will be ar raised to the power of 4. Now we have a multiplied to itself 5 times, so we have a raised to the power of 5, and we have r raised to the power 10. So this is a5 times r raised to the power of 10. This is the value that we need to obtain. Now even though we don't have the value of the common ratio as well as a, but we can rewrite a raised to the power of 5 times r raised to the power of 10 as ar squared raised to the power of 5. Now we have the value of ar squared, which is 4. So this value is simply going to be equals to 4 raised to the power of 5, which is 1024. Let's move on to the next problem. Problem number 7. In the geometric progression, it's given that the m plus nth term and the m minus nth term are given by p and q respectively. So using this information, we need to obtain the mth and the nth term. So let's begin. So we will be specifying the first term as well as the common ratio. So let the first term be represented by the letter a in lower case, and the common ratio is going to be represented by the letter r in lower case as well. Now it's given here that the m plus nth term, so a m plus n, this value is p, and using the general formula we have the first term multiplied to r raised to the power of m plus n minus 1. So this is equals to p. Let this be equation number 1. Also, it's given here that the m minus nth term, so this value is equals to q. So we have a times r raised to the power of m minus n minus 1. This value is equals to q. So this is equation number 2. Now we're going to divide equation number 1 with equation number 2. So this is going to give us a times r raised to the power of m plus n minus 1 divided by a times r raised to the power of m minus n minus 1. So that's going to be equals to p divided by q. So we have a and a cancelling out. So we have r raised to the power of m plus n minus 1. So we'll take this common ratio to the numerator and combine it to get negative m plus n plus 1, which will be equals to p over q. So here negative m, negative 1 and positive 1 cancels out. So this leaves us with the value r raised to the power of 2n equals to p over q. Now, if we take the 2nth root of this on both sides, meaning let's raise it to the power of 1 over 2n on both sides. This is also referred to as the 2nth root of taking the 2nth root on both sides. So we have p over q raised to the power of 1 over 2n. So that means our value will be equals to p over q whole raised to the power of 1 over 2n. So let's label this as number 3. Now we'll come back to the common ratio. Now instead of finding out the first term, we're going to use some tricks here, some manipulation to obtain our mth term. So here the mth term am, so this is going to be equals to a times r raised to the power of m minus 1, which can be also rewritten as a times r raised to the power of m plus n minus 1, and we are going to subtract negative n from it because we are considering n as an extra term here, which can be now written as a times r raised to the power of m plus n minus 1 multiplied to r raised to the power of negative n. Now this is done because we have already defined this, that this value is p according to equation number 1. We can replace it with p. So where p times now the common ratio, we have already obtained this value. This is p over q whole raised to the power of 1 over 2n, and we also have it raised to the power of negative n. So let's raise it to the power of negative n as well. This is going to give us p times p over q raised to the power of negative 1 over 2. So we have p times p raised to the power of negative half divided by q raised to the power of negative half. So p times p raised to the power of negative half, so that's positive half. So where p raised to the power of positive half. Oh, this is negative half here. So q will go to the numerator and becomes q raised to the power of negative half. So this is the value of our mth term, or simply put, this is square root of p times q. Now we need to obtain the value of the nth term. So our nth term, this will be equals to a times r raised to the power of n minus 1. Now we'll be using this equation number 2. So that means we need our common ratio, the power of the common ratio in this particular format, m minus n minus 1. So that means we have a raised to the power of m minus n minus 1. So here positive n, this is an extra term, negative m, and since we have n here, n value is positive, but we have considered here negative n, so that means we're going to add 2n to it. We'll get now a times r raised to the power of m minus n minus 1 times r raised to the power of 2n minus m. So this can be replaced with a value. So according to equation 2, this is q. So this will be equals to q times our common ratio. So our common ratio is p over q raised to the power of 1 over 2n whole raised to the power of 2n minus m. That means we have q times p over q whole raised to the power of 2n minus m divided by 2n. That gives us q times. So 2n minus m divided by 2n, that's 1 minus m over 2n. Further simplification is going to give us q times p over q raised to the power of 1 times p over q raised to the power of negative m over 2n. which will then give q. So q and q will get cancelled, so we have p times. So if we take the reciprocal, q over p, that will be raised to the power of positive m over 2n. So this is our nth term, which is p times q over p raised to the power of m over 2n. Let's go to the next problem. Problem number 8. So it's given here that the pth, qth, and the rth term of a GP are a, b, and c respectively. Then using this information, we need to find out the value of this given expression. So let's begin. Now here, we'll have to specify the first term. So let the first term be. So we're going to represent the first term by the letter A, but this time we're going to consider the letter A in uppercase because we already have A used here in lowercase. So we will end the common ratio. The common ratio is going to be represented by the letter R in uppercase as well. Now, it's given here that the pth term, AP, so that's equals to A, the qth term that has a value of B, and the rth term that has a value of C. So that means A times R raised to the power of P minus 1, this has a value of A. Then A times R raised to the power of Q minus 1, this has a value of B. And the other term will be represented by A times R raised to the power of R minus 1, this is equals to C. Fine. So to find out the value of A raised to the power of Q minus R times B raised to the power of R minus P times C raised to the power of P minus Q, we will use these particular values, these three values. So in place of little a or lowercase a, we have A times R raised to the power of P minus 1 whole raised to the power of Q minus R, multiplied to B. So B value is A times R raised to the power of Q minus 1 whole raised to the power of R minus P, multiplied to C. So C value is A times R raised to the power of R minus 1 whole raised to the power of, we have P minus Q. This is going to give us A raised to the power of Q minus R times R raised to the power of P minus 1 times Q minus R. Then we have A raised to the power of R minus P multiplied to R raised to the power of Q minus 1 times R minus P. Then we have A raised to the power of P minus Q multiplied to R raised to the power of R minus 1 times P minus Q. Right. So let's further simplify. So we have three first terms here. So their powers will get added. We have A raised to the power of Q minus R plus R minus P plus P minus Q, multiplied to the common ratio R, and the exponents or the power of the common ratios are also going to get added. So P minus 1 times Q minus R, so that's PQ minus PR minus Q plus R. Then we'll multiply this. So we have QR minus QP minus R plus P. Then finally we multiply R minus 1 with P minus Q to get RP minus RQ minus P plus Q. Now a couple of terms in will get cancelled out. So here positive Q, positive P, negative Q, positive R, negative R. Then PQ and negative PQ, negative PR, and then we have positive PR, negative Q, positive R, negative R, positive QR, negative QR, positive P, negative P. So it seems all the terms in the exponents are getting cancelled out. So we have A raised to the power of 0 times R raised to the power of 0, and we know that any number raised to the power of 0 that simply equals to 1. So that means the value of this particular expression is given by 1. So let's move on to the next problem. So here this is the pth term, qth term, and the other term of a geometric progression are A, B, and C. Then we need to obtain the value of this particular expression. So let's begin. Like the previous problem, we'll consider the first term. Let the first term be A in uppercase, and the common ratio will be R in uppercase as well. Given that the pth term, this value is equals to A. Now we know that the pth term can be represented as a times r raised to the power of p minus 1 equals to a. Now we'll take the logarithm on both sides. We have log of a times r raised to the power of p minus 1 equals to log of a. Now what we can do, we can use the property of logarithm, which states that whenever we have log of a times b, so this can be also expressed as log of a plus log of b. And we have another property which states that whenever we have log of a and a is raised to the power of b, then this is simply equals to b times log of a. So therefore we have log of a plus log of r raised to the power of p minus 1, which will be equals to log of a, and further simplification is going to give us log of a plus p minus 1 times log of r. So this is equals to log of a. Now here in our expression we have the coefficient of log of a is q minus r. So what we're going to do, we're going to multiply the q minus r on both sides. So we'll have q minus r multiplied to log of a. So I am writing log of a on the left hand side instead of the right hand side, and this will be equals to q minus r multiplied to log of a plus p minus 1 times log of r, which is going to give us the value. We have q minus r, so q times log of a will be q times log of a plus q times p minus 1, so qp log of r minus q times log of r. Then we'll multiply negative r to each of the terms within the parentheses, so we have negative r times log of a. Then we have negative rp times log of r plus positive r times log of r. So this is the value of q minus r times log of a. So let's represent this by equation number 1. Now it's given here that the qth term is having a value b. So our qth term, this is equals to b. So what we'll do, we can have the r raised to the power of q minus 1, this will be equals to b. So when we take the log, then we will have log of a plus q minus 1 times log of r equals to log of b. Then we'll look at the coefficient of log of b, which is r minus p. We'll need to multiply both sides with r minus p. Well, r minus p multiplied to log of a plus q minus 1 times log of r. So this will be equals to r minus p times log of b. So we can also rewrite it as r minus p times log of p. This will be equals to, so we'll distribute r minus p to each of the terms within the parentheses. So we're going to get, we'll label this as equation number 2. And then we have the rth term. So our rth term is given by c, and we can represent it as ar raised to the power of r minus 1 equals to c. So when we take the logarithm on both sides, we're going to get log of a plus r minus 1 times log of r. This will be equals to log of c. So we can also rewrite it as log of c equals to log of a plus r minus 1 times log of r. Now the coefficient of log of c, that's p minus q, so we're going to multiply both sides with p minus q. So p minus q multiplied to log of c, this will be equals to p minus q whole multiplied to log of a plus r minus 1 times log of r. So that means we now have, so we'll label this as equation number 3. Now what we'll do, we'll add equation number 1, equation number 2, and equation number 3. So let's do that. Adding all the 3 equations on the left hand side, we're going to get q minus r times log of a plus r minus p times log of b plus p minus q times log of c. Right hand side we have positive q log a. So that means all the expressions on the right hand side cancels out, and this is going to leave us a value 0. So that means the value of the given expression is 0. Let's move on to the final problem. So here in this problem, it's given that the nth term of two GPs, 5, 10, 20 and 12, 80, 640, 320, these are equal. Then we need to find out the value of n. So let's begin. So here we will consider A to be the first term. So let A be the first term and R represents the common ratio. Now for the first GP, let's consider the first GP, which is given by the first term is 5 followed by 10, 20. So here the nth term, which is defined as A times R raised to the power of n minus 1. So here the first term is 5. The common ratio is 10 divided by 5. So we're dividing the second term by the first term, whole raised to the power of n minus 1. Now that means we have 5 times 2 raised to the power of n minus 1. Then we consider the second GP. So the second GP is 1280, the second term is 640, and the third term is 320, and this goes on. Now we'll find out the nth term, which will be the first term 1280 multiplied to the common ratio. The common ratio will be dividing the second term by the first term, raised to the power of n minus 1. So 1280. Then we have 640 times 2 is 1280. So we have half raised to the power of n minus 1. Now it's given here that the nth term of the two geometric progressions are equal. So hence, thus here we can write 5 times 2 raised to the power of n minus 1. That will be equals to 1280 times half raised to the power of n minus 1. So we can further simplify this. Now we have 5 times 2 raised to the power of n minus 1 equals to 1280. So if we take the reciprocal, we are going to get reciprocal of half is 2 raised to the power of negative 1. So we have 2 raised to the power of negative of n minus 1, which means we have 5 times 2 raised to the power of 2 times n minus 1. So this is equals to 1280. So 2 times 2 raised to the power of n minus 1 is going to give us 1280 divided by 5. 2 raised to the power of 2 times n minus 1, 256. Now we know that 2 raised to the power of 8, so this value is 256. So we can equate the powers. So with 2 times n minus 1, this value is equals to 8, and solving for n, we were going to get n equals to 5. So that means the value of n is 5.